The web server we wrote in the last chapter works quite nicely. Having said that, one of the key problems with asynchronous programming in Node.js is that more than often you'll end up with the issue of callbacks inside callbacks inside callbacks. These are called nested callbacks, or jokingly referred to as callback hell. There are a number of ways of reducing nested callbacks. You can divide your script into modules, which is quite easy to implement, and this helps break down larger apps into manageable blocks. This is something you'll see in the forthcoming lectures. Another way is to avoid using anonymous functions altogether and instead declare named functions which can then be easily called in wherever needed. While these are essentially programming patterns, as far as asynchronous programming goes, there are two features that are available in ES6 that we should look into. One of them is called generators, which are essentially functions that can be paused and executed whenever needed. You can read about these in the ES6 Quick Bytes ebook that comes with this course. In this screencast, however, we'll explore promises. Let's try and understand the concept of promises first with a small story. So, imagine there is a company where there is a CFO who reports to the board. Underneath the CFO in hierarchy is the accounts head, and underneath the accounts head, we've got one or more accounts assistants. So, one fine day, the board asks the CFO to prepare and deliver a presentation on the financial health of the company. They're worried about competitors who are eating away their market share. The CFO then asks his accounts head to deliver a report with all the necessary statistics and charts. In turn, the accounts head delegates the task to the accounts assistant to collate the data as needed by him to prepare the report. So, the accounts assistant promises to the accounts head to deliver all the charts and stats on time. Based on this, the accounts head promises to compile the stats and charts into a report which the CFO had asked him to prepare. And in turn, the CFO promises to deliver the presentation with the report to the board. At this stage, the work has not begun, but we've got possible assurances from all dependencies to deliver to their parts of the promise. Now, let's examine the first scenario. In this case, the assistant does his job well and submits all the stats and charts to the accounts head. The accounts head, in turn, takes those charts and compiles them into a report for his boss. And armed with this report, the CFO delivers a fantastic presentation as promised to the board. So essentially, all levels in the chain of command delivered and their promises were resolved or fulfilled, and the task was completed successfully. Now, let's examine scenario number 2. In this scenario, the assistant delivered the stats and reports, however the accounts head was busy partying over the weekend and he totally lost out on compiling the report on time for his boss. The boss, who had thus promised to deliver the presentation, could not do so, much to the dismay of the company board. He may even get fired for this. So, in this case, the accounts head failed to fulfill his promise, and in turn, the CFO failed to deliver to his promise as well, since they were dependent. Now, mentally, replace the CFO, accounts head, and accounts assistant with callback functions as needed from various asynchronous methods in Node.js, and you'll get a picture of what we are about to do. When a function is wrapped into a promise, it can only guarantee two future states. A resolved state, in which case the function delivered what it was supposed to, and a rejected state, which can happen in case of an error, for instance. In either situation, a promise lies in the future, and till the time it is not rejected or resolved, it is said to be pending. Once it has resolved or has been rejected, then it is said to be settled. So looking back at the CFO example, this is the sort of thing we are doing in our web server code as well. The fs.access method has to tell us if the file is accessible or not before the fs.read file tries to read that in. If fs.access fails, then the read file will not be able to do its job as well. There are other scenarios which promises cater to as well, but more on that in a future lecture perhaps. For now, our task is to first make our fs.access method return a promise to let us know if the file is accessible or not, and then based on that promise, we have to make our fs.read file promise us that it will read and deliver us with the content of the file that has been requested. Finally, if both these promises are resolved, we'll serve the file to the user, or else we'll have to throw an error. Let's jump back into code now and refactor to implement promises. So we are back in the webserver.js file that we built last time, and I'll save this as webserverpro.js. Now the first thing we'll do is get rid of this portion of our code because this is what we'll implement using promises. But before that, just cut and paste out this statement where we are resolving the content type. Let's get rid of the rest. Also, we can really get rid of the code block in the listen method's callback since there is just one statement here. Now, promises till now were not available natively in JavaScript, and there were modules such as queue and RSVP which were used in Node.js to implement the same. However, now with ES6, promises are a native feature. So the first thing that we'll have to do is to promise enable both fsaccess and fsread file methods. Once they are able to return promises, they can be chained together elegantly. So outside of the web server function, I'll create a function called fileAccess, and this will be our promisified version of the fs.access method. This function will accept the file path variable since that is needed for the fs.access to do its job. Next, we'll make this function return a new instance of a promise like so. The promise itself can assure us of two possible states, a resolved state and a rejected state. So create an anonymous callback and enable this promise instance to either resolve or reject. Both of these are like outlets from where one of these states will emerge out once fs.access has done its job. Now inside the callback, we'll implement our fs.access method in exactly the same way as we did last time. The only difference is that if fs.access is able to access the file successfully, then we would need to resolve the promise, which will be done like so. When invoking the resolve, we are also packaging in the file path because this needs to travel down the pipe to the fs.read file as well. Now, if fs.access encounters an error, then we will reject the promise like so, and this time we'll pass in the error message so that it could be caught. This creates a promise enabled version of the fs.access method. Next, let's create a promisified version of the fs.read file method. I'm going to call it fileReader, and this will accept the file path as well since it will trickle down if the fileAccess method resolves successfully. Once again, we'll return a new instance of a promise, which will provide us with resolve or reject states. And here too, we'll bring in fs.read file in exactly the same way as we used last time. If fs.read file is able to read in the file, then we'll resolve the promise passing in the content so that it trickles down and we are able to serve it. And if the file is not readable, we'll reject the promise with the error. Now, one thing to note here is that if you do not specifically reject the promise and if an error happens, the promise does automatically reject by itself. However, it's best if we implement the reject invocation like so. So now we've got our two functions fs.access and fs.readFile, but this time they return promises. So let's chain them together and make them work. In the web server function now, begin by invoking the file access method and pass in the file path. This essentially returns a promise which is fulfilled if fs.access is able to access the file. We will then chain in a then method, which is a promise construct, and it essentially means that if the previous promise is resolved, then invoke the function inside the then method. So here we'll simply point to the file reader function. The file path as returned in the resolve from the file access method is automatically passed down to the file reader method. The file reader function once again returns a promise to resolve if the fs.read file is able to read the file in. So we'll again chain up a then method. By now, if the preceding promises were resolved successfully, we should have access to the content. So let's create an anonymous function and we'll bring in the content like so. And the next bit will look very familiar to you. Yes, it's our good old write head, which we are using to write a single header called content type, which is set to the content type variable. And finally, the res.end sends in the content encoded as per UTF-8. So once again, when the file access method resolves its promise, the file reader will kick in. When that resolves its promise, our anonymous method kicks in and serves the content to the user. You may be wondering why we are not converting the last then method to a promise. Well, because this function is not supposed to resolve further and is pretty much the end of line. And how do we handle errors? For that, we'll chain in a catch method. As good as it sounds, the catch method catches all errors should one or more of the promisified functions fail to resolve. So we'll intercept them through the error argument in the anonymous function, and we can throw a 500 server error, all the while sending out the actual error message to the user. I'm using json.stringify to convert the JSON error message to a string, which can then be sent across. I think here we should ideally throw a 404, since it is more likely that content not found errors will be most common. Again, actual error messages may be observed in this function and appropriate responses sent to the user. So you can see, not only do promises simplify the process of comprehending asynchronous code, it also detangles us from nested callbacks. One other plus is that when you're in nested callbacks, unless you're somehow managing errors across each callback, they don't really bubble up elegantly for us to intercept and manage. In promises, all errors from across all promises will always trickle down to the catch method, where you can incorporate your error management all in one place. This is really cool. So enjoy incorporating promises into your code. There is only one more thing left to do now. The read file method is not efficient because it buffers up every file into memory before dumping it into the response. This makes your web server a memory hog, especially if it has to serve a large number of concurrent requests. Fortunately, Node surprises us with a rather elegant trick up its sleeve. Let's see that magic in the next and concluding screencast in our quest to write a web server.